Good day, everyone. Today we are graphing polynomials. This week, take home quiz open notes will be posted on Kahoot. This quiz Kahoot will be timed and is worth 250 points like the other quiz. You get one shot of this quiz. It is going to be fast paced. But please be aware, after that one time you get, that's it. So I'm just looking for wherever your first square is I see. So if you do it twice, if you take my quiz twice, I'm going to grade the lowest score. I'm not going to look for the highest score. So again, do not, do not take it twice. Only because when we, practice and get our skills together, that is how we're going to do our retake. All right? The retake is us practicing, fixing the mistakes, all this, that, and the third. So that's what I need for you to do. Do not take this quiz no more than once. Have your notes ready and be about it. Leaving class will be limited. Usually, I'm nonchalant about you guys going to the restroom and stuff like that, but I keep crossing problems with you guys not going where you're supposed to be. In addition to, sometimes when I let you guys go to the restroom, you guys walk out without getting a pass, and you get some back by teachers who do hall monitoring. So to cut all of that, class will be limited. So if I tell you no, you know, it's nothing personal. It's just I can't let you go. Now, if you choose to walk out of class, you might as well just stay out of class because you got to deal with the consequences of that. Right? To assure that you are doing well in my class, you must be about the three. Be about your business, people. The business in Algebra 2. No more hearing about these other teachers. I can't think about those teachers. If you are doing that instead of paying attention, that's going to hurt you in your grades. Due diligence. Anytime I give you something, you always put an effort into it. Litigation. Litigation is the thing that you guys do well enough of, such as telling me about your grades, figuring out what you could do to get your grades to rise up. But then, sometimes you guys do it wrong. So, we have more of a discussion about the litigation. But litigation means that your process, when you talk to me about your grades, you got your stuff in order so I can help you out. If you wasn't handling your business and you expect me to give you a grade, that's not going to happen. Step up. All right, testing. Testing will take place from October 5th to October 14th. All right, so there's so many components of what we gotta tell you. You gotta deal with my test, you got ANET, and you got ACT. Accuracy do matter from at this point on. From now on till we finish this 9 weeks, now accuracy gotta matter because we practice. Now we gotta demonstrate skill. So you guys show me what's up. Accuracy matters. Accuracy do matter. My test, my guide. Now, I'm not gonna really print you out a formal study guide. I'm not doing that. Only because all the stuff that you really need is in Google Classroom. There's a lot of practice stuff that you can do to prepare yourself for this test. What you guys gonna be testing on, Law of exponents. That's the first thing we did. Distributive property. Quadratic, square root, and cube functions. We talked about those as well. Polynomials, which is the thing that we did the majority of the 9 weeks. So operations, add, subtract, multiply, dividing, factoring, difference of squares, cubes, polynomial facts, solving equations, and don't forget graphing. I forgot to put that on there. Graphing. Graphing. And applying polynomial knowledge is what you have to deal with. Review all additional materials such as that I posted in Google Classroom. There's some stuff that you do online that has the answers attached. It is your responsibility, not mine, for you to study. You're going to practice that. You're going to make sure you understand the material. I'm going to throw in some reviews here and there. We may have a review day, but you yourself is responsible. And you will be assessed based on knowledge. Effort I gave to you through the majority of the 9 weeks. Now we have to demonstrate because we've been practicing enough. Now we got to show what we got. Participation rubric reminders. In the beginning, when you first met me, I told you guys how you was going to get graded. Participation. So by now, if you checking your grades, you know that I give you participation points 50 a class period. You know this by now. On rare occasions when we have so much to do, when those points double. All right, participation rubric reminders. So to get points, one of the things you have to do is just talk to me. I'm not asking you to be right or wrong. Give me an answer so I could work with you. If you say 7 and that's all you say to me, guess what? I'm not going to like it. But I will give you points because you are giving me something to talk about. I may say irrelevant response, but that's something that you could at least get something. Critiquing each other. So when a person say an answer that you not a big fan of, like for example 7, you should say it can't be 7 because you have to be able to talk to me and talk to each other. Students keep disruptions to a minimum. So look, this is the thing that gets you guys in so much trouble. For example, your phone situation. I'm not one to fight you on your phones. I'm not going to do that. But a nice number of you guys are going to fail this class because for some reason your phone became more your priority than your education. If I were you, because we get a few pricks here and there. Not often, but when we do, we do. And we may use phones for technology purposes. So you guys have those opportunities, but I need for you guys to step up because that's 50 points right here. And so when you lose that 20 points, that's a 30 out of 50. If you divide that, that's a 60. And we know that's to be a F. So you may want to get it together by now. Classwork rubric. All right. So when we are doing classwork, I'm grading you on a few things what I'm looking for. When you're doing your problems, I want to see you referring to your notes. I don't care if your paper's right or wrong, Because most likely I am going to probably give you some tips and pointers, not the answer, but tips and pointers to get through things. I'm going to stop using the language this right or this wrong because it doesn't help you at the end because you feel like that's an obligation. Although I do a decent job of making you think, but telling you right or wrong and not ask you questions is not beneficial to you. So, all right. Also, you must talk to me. Ask me some good questions. I love it when kids ask me questions. The good stuff, not just is this right or wrong, but asking me, and just telling me what's up. I love it. Students are focused on the assignment. So you notice out of these 20 points, 10 of those points is just you being focused. You trying to get folks to get done, stay on task and stuff like that. You can't get points if you're on your phone, even if you are writing stuff on your paper, because I know how you kids like to say, well, I'm doing my work. Well, you may put stuff on your paper, but the issue is this. You're not putting it to understand. You're just doing it so you could fool the teacher getting points. That's not going to work for you. Doing your work is doing it to understand and master the topic, not just write stuff down because you will fail even with that. Last reminders. This is how you pass and this is how you fail, Mr. H. You pass me by responding to all my questions, correct or incorrect. You respond to each other as it pertains to the lessons, respecting the class environment, working on assignments to understand. That's how you pass. And also, when absent, you are working. So again, because I post my stuff online to you guys, you gotta handle your business. Even when you're not here, you handle it because you're still gonna be responsible for the work. How you fail, Mr. H? On your phones doing instructions, disrupting the environment in any means, copying the answers like photomath or from somebody else, doing the assignments just to finish them. Also, missing days. As I've told you guys from the jump, you must, when you are absent, you must call the school to get your stuff excused. Otherwise, you are just responsible as you are here for your work. All right? Now, this being pretty much coming towards the end of the 9 weeks, which is October 14th, is it. You gotta go step up or flunk out. That's just how it goes. Check Google even if I am absent. Check for makeups, bonus points, sub work, help for additional information. Some of you guys use to communicate, that's good too, but check on it. New way of instructions. So yeah, I kind of told you guys this a little bit, but I guess now is to make it crystal clear. So to prevent unnecessary repetition and classroom disruption, the teacher will record lessons and present them as the teacher walk around, redirect and remind the students of grades. Teachers will stop the recording to ask questions or comments pertaining to the lesson. Students will not have access to these videos until end of day. During instruction, no technology will be allowed because students miss out details. Also, when I'm providing instructions, definitely when I'm teaching, no leaving. So you ask me to leave while I'm trying to provide stuff, the answer is going to be no. Now, it's up to you to comply to that or walk out and leave. But if you walk out and leave, you do have consequences. Meaning that once you out, stay out and go ahead and deal with the consequences. All right. The good side of this is I will no longer be in your way as you're trying to write notes as I'm writing. All right, you guys, work on your project too. I was planning to go give you 15 minutes, but unfortunately, I had to knock that down to 10. Look at your rubric and look at the project 2 video that I posted. The rubric, which was attached at the end of the project information. All right, tell you how you scores, everything else. And again, look at video for the project. Once more, look at the video for the project. Look at the video for the project. Polynomial functions. Let's get to it. What's a polynomial function? We talked about this a lot. A polynomial function is an expression that's a p with exponents greater than or equal to 0. For example, 5x to the power of 0, that's a polynomial function which we know that to be 5. 5x is a polynomial function. 5x squared is a polynomial function. 5x cubed is a polynomial function, and so forth. So this table, when you hear the word degree means exponent. So if it's a degree of 0, I'm saying the exponent to be 0, which is called a constant polynomial. All right. If it's linear means I have a degree of 1 or an exponent of 1. Quadratic, 2. Cubic, 3. Quadratic, 4. Again, a polynomial function is an expression with exponents greater than or equal to 0. All right, what you want to use for now a polynomial? The answer is D. Why is D not a polynomial? Because you cannot have division in the exponent. But wait a minute, A has division too. But see, A in this case has a constant of 2. So if it's just a constant like 2, guess what? It's a polynomial. This cannot have a division sign because when you have a x in the denominator, that x is understood to be x to the negative first power, which we know that polynomials have positive exponents. Ooh, let me erase all that. All right. So notice some of this stuff is a little blurry, the stuff in the blue, but I could explain all this. So this is a polynomial function because it has a degree of 1. This is also a polynomial because it has the highest exponent or degree of 2. This is also a polynomial because it has the degree of 3 or exponent of 3. Alright, let's factor these two problems, which we've seen before, going all the way back to the factoring in the many cases that we learned. So we know this is case 1, and we know this is case number 2. So let's factor. So in case 1, using case 1, we know we put them in groups, and we could factor out x squared right here, and we get something like x minus 2 here, and we know that whatever is in my parentheses for the first, I have to have it in my second parentheses. Alright, so over here, I'm now going to pull out 5, and then what's left is going to be x minus 2. And then my final answer to this is going to be x squared plus 5 and x minus 2. Order does not matter for this. Order does not matter. You could say x minus 2, x squared plus 5. It doesn't matter how you do it. So that's my case 1. Alright, so let's do case 2. So we know that two numbers multiplied together give me a positive 45. It's negative 9 times negative 5. That gives me a positive 45, and those same two numbers, negative 9 plus a negative 5, gives me a negative 14. So from there is x minus 9, x minus 5. And that is how we factor those two problems. Alright. Alright, let's factor this one. Since we know how to do it, which factoring method is this? Swing method. What are the steps? Front times back, then rewrite x squared minus 2x minus 15. Okay, what's next? We know that negative 5 times positive 3 is negative 15, and we also know that negative 5 plus 3 equals negative 2. Alright, so we get our numbers, x minus 5, x plus 3, and let's divide it by the original front. So if I divide by 3, do I get an integer? No, I don't get an integer when I divide 5 into 3, so I got to swing it. So that's 3x minus 5. And then here, 3 divided by 3, I do get an integer, that's x plus 1. So let's solve this. We factored this already. So let's just take it from what we did in the previous. So we know our factor form of this is x squared plus 5. And we know it's going to be x minus 2. Again, What's the method we use to solve this? The zero product property, method A. So let's solve them. So subtract 5 from both sides here. I get negative 5. Now I gotta take square root of this. Now ask yourself this question. Let me rewrite this. Can I have a negative number in the square root? Put it in the calculator to find out. You realize that you're going to get an error if you try this. So, to rewrite, this negative sign becomes I. I is for imaginary. So x equals I square root 5. So let me ask you this. How many solutions do we have? You're right. It is 2 solutions. You're going to have a positive and a negative. So let's look to the right. How many solutions do I have on the right? I mean, will have. 1. How do we know that? Because this is x to the first power. Alright. Add 2 to both sides. Add 2. X equals 2. And again, we did this before, so we don't have to waste time going any further with this. Now, let's get the graphing. Since we solve them, we could graph them. So a graph of a polynomial function looks like these at the top. So I got a question for you. So what can you say about these graphs at the top? You're right. These graphs are smooth. Smooth being that you could take your pencil, and you could draw on them, and there's no gaps, leaps, or jumps. Again, a polynomial graph is smooth. There's no jumps or nothing like that. So let's look at the non-polynomial functions. Well, if I draw my pencil, it looks like it's a polynomial, but to get to the other part of the graph, I have to jump in right like that. Here, in this other graph, they don't even meet up with each other. Well, they're similar to the first. Here, this looks like a polynomial function, but it has a sharp curve, a sharp point rather. It's not a curve. It's a sharp point. These are sharp. And then here, it doesn't go all over. So again, polynomial graphs are smooth and they are symmetric around the x or y axis. Polynomial functions are symmetric either on the y or the x. In addition to, they are smooth. There's no gaps. You could take your pencil, like we did, and there's no jumps. This rational function is not a polynomial because it has a jump. This function here has a jump. This has a V shape. This does not touch cross all over, nor is it symmetric. All right? So we've seen this before. Characteristics. If I'm saying an even function by looking at the graph, what am I asking you? Well, what am I telling you? Even is symmetric around the y-axis. Another way of doing this is taking this negative x and seeing that the function stays the same. For example, if I was to say x squared here, if I was to take -1, -1 squared is positive because a negative times a negative, which is a positive. That's how you know that this is a even function. So an odd function is symmetric around the origin. You could say x-axis if you want to, but most mathematicians don't like that response. But we like to say it's symmetric around the origin. And how we know that things are odd without looking at them is plug in a -1. Like for example, if I was to say cube, we know this would be a cubic function. Well, -1 times a -1 times a -1 gonna give me -1 because two negatives gives me a positive, but if I add another negative to it, it's negative. So that's how you know. End behavior. An end behavior of a graph whose domain and range is all real numbers. The end behavior of a function describes what happens to the values of each function. So let's analyze this graph. So here, as x coming from negative infinity, y is going to be positive. So you see this part of the graph right here? So s is negative, but y is positive. And let's just have knowledge of the basic coordinate system. So let me erase this for a sec. So we know in quadrant 1, both x and y are positive. But we know in quadrant 2, x is negative, but y is positive. Remember f of x is saying y. It's the same thing, just different notations. So getting back to this, in quadrant 3, you get two negatives. And in quadrant 4, you get a positive and a negative y. So basically, that's how you read these end behaviors, just like that. So getting back to the graph, as x is negative infinity, y is positive because we know this from the coordinate system. But as the graph comes to an end, the x is positive infinity, but the y is negative infinity. All right, local of max and min of a polynomial. So guys, the right coordinate of a turning point is a local maximum of a function when the point is higher than all nearby points. So of course that means that the graph increases and that's how high as it gets. But however, the right coordinate of a turning point is a local minimum of a function when the point is lower than all nearby points. So when it decreases. All right. All right. So let's go fix these. We'll solve these algebraically. So you notice how I'm separating all this? All right. So we know the um, polynomial to the left is factor by grouping. Case one. All right. Put in the parentheses. What's greatest common factor in the first set of parentheses? X squared. What's left on the inside? X plus 4. So whatever I have in that parentheses, I should have another x plus 4 as well. And another set of parentheses. So this 3x plus 12. The greatest common factor is 3. That's x plus 4. So this is how I know I'm correct. Both of them, the inside looks the same. Now, let's put them together. X squared plus 3. X plus 4. And we know we gotta use the zero product principle, so let's set them both to 0, see what's up. On my left, how many solutions should I have? I should have 2 solutions. So let's do it. Subtract 3 on both sides. We know that we get negative 3. And you know because this is x squared, you know you gotta take its opposites. And you just take the square root of it. Can I have negative 3 in the square root? No, I can't have no number that is negative in the square root. So how do I rewrite it? I with the square root of negative 3. But because how many solutions I have, which is 2, I'm going to have plus and minus I square root 3. And I notice I see the negative sign, so I got to erase that because I can have that because that I is my negative sign that took out the square root. Alright? So let's do x plus 4 equals 0. Subtract 4 to both sides. It's going to be x equals negative 4. And those are my solutions. X plus or minus I square root 3. X equals negative 4. So those are 3 solutions. Now be cautious of this. Just because I have a square root 3, a cube in front, doesn't necessarily mean that I'm going to end up with 3 solutions. You will find out momentarily. Alright, so let's move on and do the problem to the right. So we know we did this before, swing method, all this and all that. So for my factoring, we know we get 3x minus 5. And then we know we get x plus 1. This is the result of our swing method. Alright, let's set them both to 0. 3x minus 5 equals 0. X plus 1 equals 0. Add 5 to both sides. 3x divided by 3 divided by 3. X equals 5/3. Let's do the other side. Subtract 1 to both sides. X equals -1. That's how you handle it. Just like that, y'all. We could graph them. So you guys graph them right quick for me. Alright, by now you should have graphed them, and you should have gotten for the first one this graph. For the second function, you should have gotten this graph. And as long as your graph, the shape of them looks very similar to my stuff, you may have different colors. You may, zoomed in or zoom out, but as long as they have the same shapes, you're good to go. What are graphs for? What was the whole point of looking at that? They are a visual show to show the solutions or zeros. Zeros is another word for solution because when we solve, we always get x equals something. And wherever that x is, guess what? The y coordinate is always 0. The y is always 0. So solution is, again, the answer. 0 is also no way of saying answer. The solution zeros are real, and imaginary answers we get from solving algebraically. Alright? Imaginary solutions will not be seen because they're not real. They're not going to touch the x-axis because they're not real. They are imaginary. Solutions are when the graph crosses the x-axis or the x-intercept. The x-intercept is no way of saying solution as well. So, again, x-intercept, zeros. Solutions are all the same. They mean the same exact thing. X-intercept, zeros, and solutions means the same exact thing. The answers to the equation. They also describe the behavior of these functions. You guys recall the zero product principle? You may recall method A of solving polynomial equations that when x minus a, x plus b equals 0, you end up with two equations, x minus a equals 0, x minus b equals 0. We know that a and b are roots, so roots is the same thing as saying zeros, and we know 0 is no worse than solution, and we pretty much know that that means our answer. Our x-intercept, which is also our answer to any equation. Alright? Getting back to it. Now, we can use the converse statement of this and say that if a and b are roots, then the polynomial function with these roots must be f of x equals x minus a, x minus b, or a multiple of this. If a quadratic function has roots of 3 and -2, then the function must be x minus 3 and x plus 2. Question: how will you know that the roots are x equals 3 and x minus 2, how will we check our work for this? To do this, set them both to 0 and just solve. Plus 3 here, plus 3, x equals 3, subtract 2, subtract 2, x equals negative 2. And that's how we check our work. All right. If the roots or answer or solution or 0 of a polynomial are x equals 1, x equals 2, x equals 3, x equals 4, what are the factors of these? What is that function? The function should be what? Then the function must be x minus 1, x minus 2, x minus 3, x minus 4. And we know this by setting them all to equal 0 and solving them, we get 1, 2, 3, and 4. Multiplicity of a root. Multiplicity is how often a certain root is part of the factoring. This function below has a root and a multiplicity of, this is the function right here as we see, and we realize here the multiplicity, let's look at that. That's looking at the exponent outside of this. So the multiplicity of this is going to be 2 because that's the exponent outside the factor. But the root, let's go find the root. So from here, x minus 9 squared equals 0. So let's solve it. So we take the square root of that. That's 0. And then that's just x minus 9. So now, here's something distinct that you may want to be careful about. Because you have a square root of 0, 0, 0 in the square root means you're only going to have one solution. You will not have two. And you can also graph this for yourself to find out. So, when we do solve for this, add 9 to both sides, so we know the square root of 0 is just 0. So that's 9. X equals 9. So that's the root or 0 or solution or answer to that polynomial function. All right. So that's how you do those type of problems. Y'all graph this right quick to describe the characteristics of this particular function. Put it in Desmos and see what you come up with. By now, you should have come up with this in your graph. Your graph should look like this. So here, let's look at, for now, just look at the graphs, but let's talk about let's talk about the zeros. So the zeros are, again, when it crosses the x-axis, -2, +2, and 1.8. Again, you're looking for what crosses the x-axis. All right. All right. I got a challenge for you guys. I want you to try it. I want you guys to factor, solve it, graph it to talk about the zeros and the multiplicity of this. You can work together. You can look at anchor charts, and I could point you to any directions. However, I'm going to give you a hint right now. What type of polynomial is this? Okay, this is a trinomial. Nice. All right. But from there, before you can even do anything with this trinomial, you're going to have to factor it twice. I'm going to tell you how, but one of them looks pretty obvious. But I want you guys to try it. It's a challenge problem. I want you to try it, put some effort, figure it out. Remember, I'm walking around, seeing what's up. Y'all get to it. All right, from the work, you should have something that looks like this. All right, so let me explain my work. So the first thing I did, I factored by grouping. I mean, not grouping. I factored by greatest common factor. The greatest common factor was really the exponent, which is x squared. So I pulled out the x squared, and I realized what was left. X4 minus 3x squared plus 2x. Before I moved on the side of my little scratch work, I checked my work by distributing my x squared back into parentheses to get this. That's how I know I was right. From there, was inside the parentheses, I treated it like a normal trinomial. And to me, it looked like case number 2. So I know that two numbers multiplied together to give me +2 is -2 times -1. And those same two numbers, they add up to -3. So I knew that. And once I knew that, I put them in their factor forms here. And then from there, I just solve all of them. So from there, we notice, what do we notice? How many solutions do I have? How many zeros? How many x intercepts do I have? I have 1 here, 2 here, and 2 here. So I have 5 solutions. So what can we conclude from here? What I mean is, looking at the biggest exponent in front, it says x to the power 6, but I end up with 5 solutions. Yeah, you're right. That x power to the 6, does it always mean I'm going to have always 6 solutions? No, because 2 of them became 0, so it became 1 solution because into the 0 is 0, 0 is a solution of its own. Alright, so from after I solved all of this, these are my graphs. And these got my 5 zeros. I got 0 here, 0 here, 0 here, 0 here, and a 0 there. 5 zeros. Alright, y'all. That's pretty much it.